light literally escapes a black hole. But watch the video to find out. Hey guys, welcome to What Lies Beyond a Black Hole. Today, we will unravel the mystery of a black hole and what actually lies beyond it. Can we pop out at the other side? And if so, what is it like? So stay tuned as the mystery unfolds. So what is a black hole? Well, in simple words, it's an astronomical object up in the space with an unthinkably strong gravitational force that even when light tries to pass through it, the force of gravity increases the escape velocity past the speed of light, and so light ends up falling back in and getting trapped. Yes, you heard it right. Not even light, which is the speed of the cosmos. They are made of matter packed so tightly that gravitational force overwhelms all other forces. Think of it like a bowling ball. When you pick it up, it's heavy. Imagine putting more and more mass into that tiny space. Eventually, it would exert such a strong gravitational force that even nearby rays of light would not escape it, let alone human bodies. They are formed when massive stars in the sky run out of fuel for fusion reactions, which keep them hot and bright. Once they collapse at the end of their lives, they explode, leaving behind a very compact and dense arrangement of mass called a black hole. So it's a one-way ticket. You can get in, but you cannot get out. Its surface, called the event horizon, is the point where the speed to escape exceeds the speed of light. In other words, it's the point of no return. So now let's talk about the black hole. What do black holes look like? Can we see them so that we know where their territory starts? Well, no. We can't see them as they're invisible. No light is emitted by black holes, so they cannot be seen. That's very scary. You wouldn't know when you have entered their area, should you, against all odds, make it to a black hole. But scientists have developed various ways of detecting them. By looking for objects that are falling in because they are entering a black hole, they travel in such a high speed that they get hot and glow very brightly, which scientists can detect. They can also be detected by observing objects traveling around them. Due to their immensely strong gravitational pull, nearby objects start orbiting them. So, scientists can detect strange movements of objects around a path of empty space and see where a black hole exactly is. When two black holes collide in space, they cause ripples in space-time, which is yet another way scientists detect the presence of black holes in space. Let's discuss what's beyond a black hole. The honest answer to all these questions is pretty much what Professor Richard Massey says. Who knows? Massey, a researcher at Durham University who studies space and black holes, knows at that point there's no way to send a message back. The gravity is so strong it would tear them apart, so it's unlikely they'd get very far anyways. So if you ever find yourself at the event horizon or the point of no return, the extreme gravity would stretch your body into thin strands of atoms, a process scientists nicknamed spaghettification. In the end, you'd be crushed into the center, known as the singularity. The idea that you could come out the other end in one piece is pure science fiction. However, there is a possibility that these black holes could be wormholes or pathways to other galaxies or to other universes. That sounds amazing. Seems like science fiction isn't fiction at all. However, there is no concrete evidence that supports the existence of such theoretical tunnels leading to other galaxies. Light cannot escape a black hole, so no picture or video can be snapped by a camera. So no matter how advanced our cameras get, the possibility of seeing what's inside a black hole remains slim, very slim. According to current theories, anything that crosses the event horizon becomes part of a black hole. And since time gets weird near that edge, so it would look like all this happens in super slow motion, so don't expect answers anytime soon. I think the standard story is that they lead to the end of time, said Douglas Finkbeiner, professor of astronomy and physics at Harvard University. According to the professor, an observer far away will not see their astronaut friend fall into the black hole. They will just get redder and dimmer as they get close to the black hole, thanks to something called gravitational redshift. But from their point of view, they fell straight into a place beyond forever. Another theory is that they could lead to white holes that exist in the past. But what are white holes now? Well, like black holes, white holes do not allow light and matter to pass through, but light and matter will not be able to enter. Well, the universe is strange. You can't enter some and can't leave some. Scientists are still looking into whether black holes and white holes might be connected. In a 2014 study, physicists Carlo Rovelli and Hal M. Haggard suggested that it's possible for matter to fall into a black hole and later come out of a white hole. Basically, they're saying that everything a black hole swallows could eventually be spit back out, and when a black hole dies, it might actually turn into a white hole. Instead of destroying everything it takes in, a black hole might actually stop collapsing and do something called a quantum bounce. Basically, it could release that information back out. If true, this idea could support what Stephen Hawking suggested back in the 1970s, that black holes give off tiny amounts of heat and particles because of quantum effects. Hawking said black holes don't last forever, explains Finkbeiner in a 1976 paper. Hawking showed that this radiation would slowly drain a black hole's energy until it shrinks and disappears. But he also believed the radiation was totally random and didn't carry any clues about what went in, meaning when the black hole finally explodes, all that information would be lost forever. Still, physicists Ahmed Almhiri, Donald Marloff, Joseph Polinsky, and James Soley thought Hawking might have been onto something. They came up with a theory called the AMPS firewall, or black hole firewall hypothesis. According to their math, quantum mechanics could turn the edge of a black hole, the event horizon, into a blazing wall of fire. Anything that touches it would burn instantly. If that's true, black holes don't lead anywhere because nothing could even get inside. But here's the problem. That idea clashes with Einstein's theory of general relativity. According to Einstein, someone falling into a black hole shouldn't feel anything dramatic at the event horizon. They'd be in free fall, just like in space, and shouldn't notice any extreme effects. If the firewall idea is right, it either breaks Einstein's rules, messes with quantum field theory, or suggests that information really can disappear, none of which scientists are too happy about. In 2014, Stephen Hawking shook things up again. He suggested that black holes might not have a traditional event horizon, the point of no return, but instead something called an apparent horizon. This temporary boundary would trap light and matter for a while, but eventually let it escape. That fits better with quantum theory, which says information can't just disappear. In fact, Hawking even said black holes might not truly exist the way we think. He described them as unstable zones of gravity, not dense points with a singularity at the center. In his view, matter never fully collapses inward, it just gets stuck for a time. But even if black holes do release stuff eventually, the problem is, it's all jumbled. You wouldn't be able to tell what originally went in by looking at what comes out. Not great news if, say, a person fell in. This mystery is far from solved. Researchers like Rovelli and Vidito have proposed that the remains of black holes might even help explain dark matter. And Hawking's later work on soft hair, leftover particles around the edge of black holes, suggests that maybe information isn't lost, just stored in a strange way. All this challenges an older idea known as the no-hair theorem, which claimed all black holes look the same from the outside. But now, with so many theories floating around, scientists are still deep in the puzzle. One thing's clear: we'll be thinking about this for a long time, unless someone finds a safe way to dive into a black hole. Conclusion? So the answer to what lies beyond a black hole is, we don't know. These are the theories which have been put forward by scientists over the years, but there is no definitive answer. Well, that's it for today. If you like this video, hit the like button, share, and don't forget to subscribe. We will be back again with another exciting video. Until then, goodbye.